CIET NCERT presents Audiobook of Mathematics for Class 5 entitled MATHMAGIC 5. This is the Chapter 3.
Part 1.
Page 34. How many squares? On the page we have a picture with many dots. A rectangular boundary is created by joining the outermost dots, and within the dots, to the left corner of the top edge, we see a red square created by joining the 4 dots. Below the figure we have some questions. Measure the side of the red square on the dotted sheet. Draw here as many rectangles as possible using 12 such squares. How many rectangles could you make? Dash. Below the picture we see some kids exploring, thinking and doing the work by creating some red squares. One boy is thinking, whereas a girl and a boy are busy creating a pattern of red squares, one row on top of the other, and as they do this, the girl is happily cheering. Here's one. Each rectangle is made out of 12 equal squares, so all have the same area, but the length of the boundary will be different. On the right side towards the bottom of the page, we see the picture of a bird. The bird is telling us length of the boundary is called perimeter. Questions. Which of these rectangles has the longest perimeter? Which of these rectangles has the smallest perimeter? Children are not expected to learn the definition of the term area, but develop a sense of the concept through suitable examples. Give them many opportunities in the classroom to compare things in terms of area and guess which is bigger. Things like stamps, leaves, footprints, walls of the classroom, etc. can be compared. Page 35. Measure stamps. On the top of the page, we have a grid-like structure in which we see the pictures of a number of stamps neatly arranged in different sides and corners of the figure. These stamps have been marked as A, B, C, D, E, and F. Below the picture we have some questions. Look at these interesting stamps. A. How many squares of 1 centimeter side does stamp A cover? Dash. And stamp B? Dash. To the right side of these questions there is another bird which is telling us stamp D covers 12 squares. Each square is of side 1 centimeter, so the area of stamp D is 12 square centimeters. B. Which stamp has the biggest area? How many squares of side 1 centimeter does this stamp cover? How much is the area of the biggest stamp? Dash square centimeters. C. Which 2 stamps have the same area? Dash. How much is the area of each of these stamps? Dash square centimeters. D. The area of the smallest stamp is dash square centimeters. The difference between the area of the smallest and the biggest stamp is dash square centimeters. Collect some old stamps. Place them on the square grid and find their area and perimeter. Page 36. Guess. A. Which has the bigger area? One of your footprints or the page of this book? B. Which has the smaller area? 2 5-rupee notes together or a 100-rupee note? C. Look at a 10 rupee note. Is its area more than 100 square centimeters? D. Is the area of the blue shape more than the area of the yellow shape? Why? Below the question we see a blue and a yellow shape. Yellow shape is a combination of two triangles put together creating a rectangle, whereas the blue shape is again formed by two triangles, but they are adjacent, so they form a bigger triangle. E. Is the perimeter of the yellow shape more than the perimeter of the blue shape? Why? How big is my hand? Trace your hand on the squared sheet on the next page. How will you decide whose hand is bigger, your hand or your friend's hand? What is the area of your hand? Dash square centimeters. What is the area of your friend's hand? Dash square centimeters. Page 37. On top of this page we have a grid structure made by many squares. Below this there is a picture. A boy and a girl are making their footprints on the sand below. The boy tells the girl, "My footprint is longer." The girl responds by saying, "But my footprint is wider. So whose foot is bigger?" My footprints. Question. Whose footprint is larger, yours or your friend's? How will you decide? Discuss. Is the area of both your footprints the same? Page 38. We have the picture of some animals and birds on top of the page. A baby rhino tells us, "My skin has many folds, so I have a big area. This way the air all over me keeps me cool." An elephant is asking us, "What is the area of my footprint?" Next to it we have an ant asking us, "What is the area of my footprint?" A curious bird is looking at these animals on the right side. Guess which animal's footprint will have the same area as yours. Discuss. Here are some footprints of animals in actual sizes. Guess the area of their footprints. Below this we have the picture of a boy with a hen, and next to it we see the footprint of hen in actual size. Below that a girl is seen with a dog, and to the right of that we see the footprint of the dog in actual size. Page 39. On this page we see a huge picture created by many square grids. On the top right corner we see two boys peeping over and watching a tiger who's telling us, "Make big squares and rectangles like this to find the area faster." On the grid lines we see the footprint of the tiger in actual size, and his suggestion will be really helpful to find the area faster. For the teacher, at this stage, children need not count each square. Encourage them to identify the largest squares and rectangles within a footprint to know their area, and then count small squares for irregular shapes. Though area of a rectangle will be done in Chapter 11, some children may discover themselves that they can find the area faster through multiplication.
Part 1.
The Chapter 3 ends here. CIET NCERT presents Audiobook of Mathematics for Class 5 entitled MATHMAGIC 5. This is the Chapter 3.
Part 2.
Page 40. How many squares in me? On the page, we have some pictures. The first one is a conversation between a boy and a girl. We see a rectangular figure between them which is created by two squares on top of the other. The figure is cut diagonally from the top right to the bottom left corner, creating two triangles. The girl on the left is asking, "What is the area of this triangle?" The boy is telling, the triangle is half the rectangle of area 2 square centimeters, so its area is dash square centimeters. Below that, we have another conversation between a boy and a girl. In between them, we see a big rectangle in which there is a shape of curves drawn. The girl is asking, "Is this shape half of the big rectangle?" The boy is thinking, so its area is dash square centimeters. Question. Write the area in square centimeters of the shapes given. Again we see the picture of a huge grid created by many squares. Within these grid lines we see a lot of geometrical figures drawn and marked as A, B, C, D, E and F. For the teacher. In this exercise, children are expected to notice the geometrical symmetry of the shapes to find out their area. Encourage children to evolve their own strategies. Rounding off is not needed in these examples. Page 41. Try triangles. On top of the page, we see a grid line structure as the base on which two triangles are drawn, one blue in color and one red. A girl, Samina, and a boy, Sadiq, both are looking at these triangles. Samina says, "Both the big triangles in this rectangle have the same area." Sadiq is thinking, "But these look very different." Sadiq continues by saying, "The blue triangle is half of the big rectangle. Area of the big rectangle is 20 square centimeters. So the area of the blue triangle is dash square centimeters." Samina asks, "And what about the red triangle?" Sadiq replies, "In it there are two halves of two different rectangles." And then we see a bird on the bottom right of the page telling us, "Now you find the area of the two rectangles Sadiq is talking about. What is the area of the red triangle? Explain." Page 42. Sadiq says, "Yes, you are right. And you know what? You can draw many more triangles of area 10 square centimeters in this rectangle. Try drawing them." Help Sadiq in finding some more such triangles. Draw at least 5 more. Complete the shape. Suruchi drew two sides of a shape. She asked Asif to complete the shape with 2 more sides so that its area is 10 square centimeters. We have 2 pictures. On the left side, there is a grid line structure of squares in which an incomplete figure has been drawn by Suruchi, the top of a triangle perhaps. And on the right side, we see the same figure being completed by Asif. He joined the 2 lower ends of the figure to create another triangle downwards. He completed the shape like this. Suruchi asks, "How did you do this?" Asif replies, "Oh, that's easy. If you look at the green area, it is 4 square centimeters. Below it is the yellow area of 6 square centimeters. So the area of my shape is 10 square centimeters. Questions. Is he correct? Discuss. Explain how the green area is 4 square centimeters and the yellow area is 6 square centimeters. Page 43. On the top of the page, we again see Suruchi and Asif conversing. This time, Suruchi has drawn the bottom triangle in a different way, which is present here in blue color. Suruchi is telling Asif, "Oh, I thought of doing it differently. If you draw like this, the area is still 10 square centimeters." Questions. Is Suruchi correct? How much is the blue area? Explain. Can you think of some other ways of completing the shape? Try some other ways yourself. Now ask your friends at home to solve these. We see the picture of a girl next to the questions, thinking to herself, "Every time guests come home, I ask them to do this, but why do they run away?" Practice time. 1. This is one of the sides of a shape. Complete the shape so that its area is 4 square centimeters. To the right side of the question, we see a square grid with one sloping line drawn at approximately 45 degrees. 2. Two sides of a shape are drawn here. Complete the shape by drawing 2 more sides so that its area is less than 2 square centimeters. On the left side of the question, we see again a square grid with 2 sloping lines drawn, which are meeting at the top, like the point of a triangle. For the teacher. Children can be encouraged to make shapes with either straight edges or curved edges to cover the given area. This exercise can be extended by asking children to draw on squared paper as many shapes as they can of a given area and making guesses for the largest or the smallest perimeter. They can also be asked to check their guesses by measuring the dimensions of the shapes. In case of curved edges, thread can be used for measuring the perimeter. Page 44. 3. Here is a rectangle of area 20 square centimeters. Below this we see 2 rows of squares, one on top of the other. Question, Part A. Draw one straight line in this rectangle to divide it into 2 equal triangles. What is the area of each of the triangles? Part B. Draw one straight line in this rectangle to divide it into 2 equal rectangles. What is the area of each of the smaller rectangles? Part C. Draw 2 straight lines in this rectangle to divide it into 1 rectangle and 2 equal triangles. What is the area of the rectangle? What is the area of each of the triangles?
Part 2.
The chapter 3 ends here. CIET NCERT presents Audiobook of Mathematics for Class 5 entitled MATHMAGIC 5. This is the chapter 3.
Part 3.
Page 44. Puzzles with 5 squares. Measure the side of a small square on the squared paper on page 45. Make as many shapes as possible using 5 such squares. 3 are drawn for you. Page 45. We see the picture of a large square gridded space with the 3 shapes already drawn for the students using 5 squares. Rest of the shapes have to be drawn by you. Question, Part A. How many different shapes can you draw? Dash. Part B. Which shape has the longest perimeter? How much? Dash centimeters. Part C. Which shape has the shortest perimeter? How much? Dash centimeters. Part D. What is the area of the shapes? Dash square centimeters. That's simple. Page 46. Did you get all the 12 shapes using 5 squares? Below this question we see the picture of that square grid with 12 shapes shown in different colors. Besides this picture, we see a bird standing and telling us, all 12 shapes are arranged here to make a rectangle. This is a 10 by 6 rectangle as there are 10 rows and 6 columns. You will be surprised to know that there are more than 2,000 ways in which these shapes make a 10 by 6 rectangle. Draw all the 12 shapes on a sheet of cardboard and cut them. Try to arrange your 12 shapes in some other way to make a 10 by 6 rectangle. Could you do it? Try another puzzle. You have to make a 5 by 12 rectangle with these 12 shapes. There are more than 1,000 ways to do it. If you can find even one, that's great. Page 47. Game time. Here is a chess board. Play this game with your partner with one set of 12 shapes. Below this we see a chess board and 2 kids playing on it. The first player picks one shape from the set and puts it on the board, covering any 5 squares. The other player picks another shape and puts it on the board, but it must not overlap the first shape. Keep taking turns until one of you can't go any further. Whoever puts the last piece wins. Make your own tile. Remember the floor patterns in MATHMAGIC Book 4, pages 117 to 119? You had to choose the correct tile which could be repeated to make a pattern so that there were no gaps left. For the teacher. Encourage children to try to do these pentomino puzzles at home. Such exercises can be designed for shapes with 6 squares, that is, hexominos, in which case there will be 35 different shapes possible. Page 48. Ziri went to a shop and was surprised to see the different designs of tiles on the floor. Aren't these beautiful? We see 3 different designs of tiles displayed here, with all different colors, shapes and patterns drawn on them. Question. Can you find the tile which is repeated to make each of these floor patterns? Circle a tile in each pattern. After looking at the patterns, Ziri wanted to make her own yellow tile. You too make a tile this way. Step 1. Take a piece of cardboard or thick paper. Draw a square of side 3 centimeters on it. Step 2. Draw a triangle on any one of the sides of this square. Step 3. Draw another triangle of the same size on another side of the square. But this time, draw it inside the square. Step 4. Cut this shape from the cardboard. Your tile is ready. What is its area? Page 49. Make a pattern using your tile. Trace the shape to repeat it on a page, but remember, there must be no gaps between them. Ziri made a pattern using her yellow tiles. You know the area of her tile. Below this we see Ziri and the pattern she made using her yellow tiles. Answer these. How many tiles has she used? What is the area of the floor pattern Ziri has made here? Practice time. Ziri tried to make some other tiles. She started with a square of 2 centimeters side and made shapes like these. We have 4 different shapes shown here. They are marked A, B, C and D, and all of them are in different colors. Look at these carefully and find out which of these shapes will tile a floor without any gaps. Discuss. What is the area of these shapes? Make designs in your copy by tiling those shapes. Now you create your own new tiles out of a square. Can you do the same with a triangle? Try doing it. For the teacher. In class 3 and 4, basic shapes like squares, rectangles, hexagons, triangles, circles, etc. were used to examine which of those can tile and which do not tile to make floor patterns. Children must now be able to modify basic shapes to create different tiling shapes. In the exercise above, they may create new shapes out of a square that do not tile, even though their area remains the same as that of the square from which they are made.
Part 3.